So here we have an oblique triangle, and we're going to talk about the law of sines and where it comes from. So what I'm going to do for this oblique triangle is I'm going to draw an altitude, and I'm going to go from the top here down. I should have labeled my triangle first. So alpha, beta, gamma, and then the sides A, B, and C. Now remember, B is all of this side. Okay, just remember that. I'm also going to label my altitude. I'm going to label it H for height. That's pretty standard that they use an H. Well, because I have this right triangle, like I have a right triangle right here, I know something in the world of trigonometry. I know the sine of alpha is equal to opposite H over the hypotenuse. Now, if I were to solve for H, so multiply by C, I get that. Okay, I can do that. But look, I also have a right triangle over here. So I can say, if I use gamma, I can say the sine of gamma is equal to H, the opposite, over A. And so A sine gamma is equal to H. So now I have two things equaling H, C sine alpha and A sine alpha. C sine alpha equals A sine alpha. Sine gamma, sorry. Sine gamma. But we would like to have it a little cleaner. And so what they're going to do is they're going to multiply both sides by 1 over AC. And that's going to give you sine alpha over little a. And on the other side, you're going to have sine gamma over little c. Now, when I said that makes it a little cleaner, notice that you have on the left alpha and a. So you have the angle and the side across from it. And on the right, the same thing, gamma and c. Okay? So the angle and the side across from it. Now you could do this again and draw a different altitude and come up with beta, but these are going to all be equal to each other. And so here's the law of sines. The law of sines. It says sine alpha over A is equal to sine beta over B, which is equal to sine gamma over C. You can also write the reciprocals. So if you want it the other way, you can write A over sine alpha equals B over sine beta equals C over sine gamma. Now, I've taught out of different books. I always see the law of sines written this way, where it's like 3 pieces to 2 equations. But you only need 2 pieces when you're solving. So you have to decide, okay, what angle do I know? What sides do I know? Which part am I going to use? You're not going to use all 3 parts. Okay, but you'll see that in an example. Well, to show you, so let's say you had a triangle and you knew alpha was 10 degrees or something, and this side was 3.7 meters. And you knew this angle up here, beta, was, I don't know, 79 degrees or something. Then what you could do is you could take, you'd want to use the alpha beta part, because that's what you know information for. So you would say the sine alpha over A is equal to sine beta over B. And let's say you're trying to figure out what B is. That's supposed to be beta. And then, see, you have enough information. You could say the sine of 10 degrees over 3.7 equals the sine of 79 degrees over B. And it's a proportion, and you can solve that, and you'd use a calculator to get a decimal approximation. Okay, but I'm just kind of previewing what's coming next. I bet the next example is that.